Hello friends, welcome back to my YouTube channel. This is Assistant Professor Ramdas Pandit. In this video lecture, we are going to study about the titration of a strong base and a weak acid. Now you will think strong base, the pH will be higher than 7, okay, more than 7, okay. Strong is there, so it will be near about 14 or greater than 10, okay. And you will see here the weak acid is given, so that will be the pH less than 7, or weak is given, so you will think it is near about 7, okay. So in this titration, let us consider the titration between zero point 0.1 normal NaOH and zero point 0.1 normal acetic acid. That is, formula is given CH3COOH. Okay, and in this case, you will see here NaOH is the strong electrolyte. How we can identify NaOH is the strong electrolyte and CH3COOH is the weak electrolyte? How? Because we have no NaOH is the complete dissociation occur, and in the acid, or we can say the acetic acid, it is not completely dissociate. So we can say NaOH is the strong electrolyte and CH3COOH is the weak electrolyte. Okay, so in this way we can determine which one is strong electrolyte and which one is weak electrolyte. So NaOH is the strong electrolyte, so that we can take into the bibutyrate. Okay, and here acetic acid is tighter, we can consider is tighter, and NaOH is the titrant, right? Now we have taken that much volume 25 ml of zero point 0.1 normal acetic acid by pipette into the conical flask, okay, and we have filled NaOH into the burette. So the pH of acetic acid will be, I told you, near about 7, less than 7 and near about 7. So the graph will be, the curve will be in this way. You can see the pH on y-axis and the added NaOH, it is on x-axis, okay. So when you are adding the base into this acetic acid, so pH will be going increases like this, in this way. Now we have to see in detail about this curve, okay, stepwise, like a previous lectures, okay. So at the first stage, what will be happen without addition of NaOH? So what will be the pH of this solution? Okay, before that we have to see the characteristics of that titration curve, or we have to see the feature of that titration curve. Now we have no titration curve for the strong base and weak acid that we have seen. Now we have to see the one by one point in this curve. The first stage, that is the pH at the start, is nearly 3. You can see here, okay, at the start stage it is near about, pH will be 3, okay, here. Now the second point, there is a little bend at the start of the titration, little bend you can see here, okay. And the next point, that is when the you will add 24.5 ml of NaOH, the pH increases rapidly. Obviously, we will add that much volume of NaOH into the acetic acid, so the pH will be the increases rapidly or so fast, okay. So in this way you will get the curve, titration curve, okay. And after addition of 24.9 ml of NaOH, so there is an upward bend in the curve, okay. So from this curve you will get, after addition of 24.9 ml of NaOH, okay. And the vertical part of the titration curve covers 6 to 10.5 pH units. You will see from this point, okay, from this point. So you will consider like this 6 to 10, 6 to 10. So for this vertical region, so that will be the pH unit, okay. So obviously the equivalence point between 6 to 10.5, and that is the 8.73, okay. So for this titration the equivalence point is 8.73, so that will be the here, okay. Now in that region you can see which indicator is coming. You can easily see here, okay, that we have to see which one is the best indicator for this kind of titration. So we have to see the choice of indicator for this kind of indicator or titration, okay. Now choice of the indicator you can see, that is the pH unit around equivalence point 6 to 10.5 pH unit. So we have no the pH transition range for this indicator bromothymol blue, that is 6.7.6. In this case we have taken only two indicators, that is bromothymol blue and phenolphthalein indicator. And why we have taken only two indicator? Because you can see here the pH unit, that is 6 to 10.5, okay, and you will see the pH transition range for this indicator, that is 6 to 7.6, and for the phenolphthalein 8.3 to 10, okay. So you can say, so both indicators are suitable for this kind of titration, okay. So but which one is the best, that we have to identify, okay. That is the choice of the indicator, because in one titration we can use only one indicator. So which one is the best, and we should know the equivalence point for this titration, that is 8.73, and you will see this value, you will see between the this pH transition range of phenolphthalein indicator 8.3 to 10. So between this range these values is going to fix. So the you can easily say the base indicator for this kind of titration, so that is phenolphthalein indicator. That means for the strong base and weak acid titration you will use the phenolphthalein indicator to determine the endpoint to complete the transition range of this reaction, okay. And now we have to see when you are adding the base into the acetic acid at state wise, so how they are pH changing, okay. You will see the titration of NaOH, that is zero point 0.1 normal with acetic acid 0.1 normal, okay. And you will see this table, this table is given. If you will add the BS 2 ml, that time the pH of this solution will be 3.7. You add the 5 ml, the pH will be 4.6, okay. You add the 15, 4.93. In this way you can see, if you add the 14.5, the time the pH will be 6.45, okay. And if you will add the 25 ml of NaOH in the 25 ml of HCl solution, okay, so that times you are getting the 8.73, that is the equivalence point, okay, in this kind of titration. So we have to see by calculation how pH changing if you are adding specific amount of volume of base into the acid.